recording and manipulating and working with when we are doing NAT. In order to understand how NAT operates now, we need to understand the difference between local and global areas of our network. Now, when we talked about how the firewall operates, we talked about the inside trusted area and the outside untrusted area. And typically with NAT, these correlate that our local network is affiliated with our inside trusted network and that our global network is affiliated with the outside and untrusted network. Is this always true? No, this is not always true. The idea here with NAT is that we need to identify a local area for the packet to exist and a global area for the packet to exist. And what we'll do is we will record information of the packet when it's in the local network. We'll manipulate the packet header and then send it over to the global network to get sent out. And then we'll reverse the process when it comes back. So local and global are identifying which side of the NAT device that we are talking about. This will prove useful for us because in order to apply NAT, when we're doing dynamic NAT, we need to really have a good understanding of local versus global. Now we're going to start simple here. We're just going to have one single user in our house trying to reach a website out on the public internet. So they're going to try to browse to 203.0.113.100 on port 80, which is some website, and my source IP address is 10.0.0.10. And we've established that if I try to send this message out to the internet and get a reply back, that is going to fail because my source IP address is 10.0.0.10, a private address. So the way that we get NAT to work is before we send the message out to the global network, as it arrives on our firewall and there's a NAT rule to be applied, what we will do is we will record our source IP address and port number as the inside local address, meaning this is our source IP address on the local side of our NAT translation. We're also going to record our outside local address. This is our destination IP address when the packet is in our local side of NAT. All right, so when it's in the local network, before it moves out to the global network, we record the inside local and the outside local addresses. Now, before we send that message out to the global internet, we need to record some more information and we need to change our source IP address so that we can get out to the public internet. So we're going to apply our NAT rules here. We're going to grab the public IP address from the outside interface of our firewall, which in this case is 198.51.100.10. We're going to record that in our NAT table as our new inside global IP address. So when the packet is on the global side of the network, the source IP address is going to be that public IP. So we change our packet header. Before we forward that message on, we need to record our outside global address, which is again our destination address. Now we can forward that message out to the internet. The website processes it, returns it back to our home network. Now the destination address is 198.51.100.10. We look up in our NAT table. This is our inside global address. We can then move our packet to the inside of our network. We can examine our NAT table, see that the destination needs to be translated back to our inside local address. So we translate from 198.51.100.10 back to 10.0.0.10. Now I can forward my message on to my workstation and I get the website. So much like we're keeping the state of the TCP session in our TCP state table, with NAT, we're keeping a network address translation table that maps what our local packet looks like, maps what our global packet looks like, and then allows us to translate between one and the other. This next section, I'd like to explain how we apply NAT when we do it with static rules, where the administrator statically sets the global address and the local address so that users on the outside of our network in our global side of our network can reach devices on our local side of the network. I'm going to use the same exact example I used from the previous module. Here I have an internet PC that wants to browse to a web server. We can assume this is our Star Wars fanboy again, trying to get to our Global Mantix web server that has all that Star Wars memorabilia on it. Now I've already set up my access rule to allow the internet PC to come in and get to the web server. The problem is that in the previous module, we did not talk about NAT yet. So I made an assumption that the internet PC could route to 192.168.10.10. The reality is that that PC cannot route to that network. So we need to set up a static translation so that the internet PC has a global address to reach our web server on the local network. So we'll establish our local inside network as the side that the web server is on, and our global outside network as the side that the internet PC is on. We need to know what IP addresses our internet service provider gave us. Now we're a small business and we have a 198.18.42.2/28 IP address on our outside interface with a default gateway set of 198.18.42.1, which means that I've used up 2 IP addresses in my /28 range. My /28 range has addresses 42.1 through 42.14. I've used 2 of those, which means that I have 42.3 through 42.14 available for me to use. So what I can do here is I can create a static NAT rule that says my global address is 198.18.42.8, going to my local address of 192.168.10.10. So I have my message. Our Star Wars fanboy wants to get to our website, so he puts in the destination IP address of 198.18.42.8. That gets forwarded to the firewall. We see that there is a rule to translate the 198.18.42.8 into 192.168.10.10. Once we do our NAT translation, then we can check our access rule. Our access rule says that we are legit. We can pass through the firewall, and now we can forward our message onto the web server. Now you should notice something here. This particular firewall, the way I have it configured, it processes NAT first, then it processes the access rule. On the firewall that you work with, you're going to have to find out what order your particular firewall operates. Some firewalls will make you put the access rule in using the global address. Others are going to make you use the local address. And it all depends upon when that NAT is happening, because that access rule is looking exactly in the packet and segment headers. NAT can modify those, so we have to make sure that we have the right order of application of this. All right, now back to NAT. Our web server got the message. The web server can now reply to the message, send it back to the firewall. The firewall will then take the private address out, replace it with our global address, and forward it on to our fanboy out on the internet. So there's how static NAT operates. Static NAT isn't always that simple though. A lot of us have in our home networks a situation where we only have one single IP address to use. So here my ISP gave me 198.18.42.2/30, which means I have .1 and .2 to use on my network. .1 is the router for my internet service provider, and .2 is me. So now if I want that internet PC to reach my web server, I don't have any extra addresses on my untrusted zone or my global network to use. What that means is I can actually reuse the IP address on my outside interface. And this is something called port forwarding, but it's actually a form of static NAT. And what we do here is we say if we receive a message on our outside interface that has a global address of 198.18.42.2, the same as the IP address on our untrusted interface of our firewall, but it also has a destination port of 80. When those two characteristics match, then forward it on to our inside local device. Sometimes we may have already used port 80 on the outside interface, or we need it for something else. And with static NAT port forwarding, we can actually change our global port number to be whatever we want it to be. So we could make our internet PC user out there, our Star Wars fanboy, we could make him browse to a website that's at 198.18.42.2 on port 8080 to allow that user to get back into the web server. And I'll show you exactly how this works in a demonstration so that we can see that we browse to the website on the internet side to a strange port number, but we're still accessing the web server on port 80 on the inside of our network. Let's do a demonstration and see how this actually works. So what I want to do is examine inside to outside dynamic NAT so we can see what it looks like when we're surfing the internet from our home computer. We can take a look at what our packet looks like on our local network and compare it to what it looks like on the global network. So here in my drawing, really what I want to accomplish is to allow that inside PC to communicate with my outside web server. Now in the previous module, the way I had this set up was the cloud that I have drawn in here. Well, part of my setup is in that cloud. It's what allows me to connect the internet PC and the outside web server to the outside interface of my firewall and have access to it in my network. And what I did was I set up a route in the cloud so that 10.0.0.0/24 was completely accessible from my version of the public internet here. However, now that we've talked about NAT, we know that that can't actually happen. So we need to set up our NAT rule to allow our inside PC to talk to our outside web server. So that's going to be our goal here, is to get that inside PC to get to that outside web server's website. What I want to do that is I want to use some Wiresharking to take a look at what's happening before we do NAT on the inside PC and the outside web server, and then do some Wiresharking after we configure NAT and see what's happening then. So right now I want to open up my web browser. I'm going to use Google Chrome here, and I'm going to browse to 198.51.100.100. Now that is my external website, the outside web server, and right now that's just not going to load. And it's not going to load because I do not have NAT yet configured. Let me stop this and launch Wireshark and get a capture started with Wireshark here. And in my filter, I'm just going to put the IP address of the outside web server, 198.51.100.100. So we only see that traffic, and then I'm going to pull up my browser again here. We'll take a look at both happening at the same time. So if I refresh, HTTP 198.51.100.100, and I hit enter there, what's happening here is I'm seeing that my workstation, 10.0.0.99, keeps sending SYN messages to the web server, and I'm not getting any replies. Let's jump over to our outside web server and take a look at what's happening over there. Before I do that, I'm going to stop my web browser here from sending traffic, and we're going to move over to my outside web server. Okay, so now I've moved over to my outside web server. I want to launch Wireshark. Launch up Wireshark here, and I'm going to put a filter in here to say that I want to look for IP addresses from 10.0.0.99, which is what I should be receiving on this box, considering NAT has not yet been done. What you can't see me doing right now is refreshing my web browser on my inside PC. So I just hit the refresh key. The whole process kicks into action. I'm going to stop this capture already and just see what happened here. Scroll up right to the top. So we can see the inside PC sending the SYN message to my web server, and the web server sending a SYNAC back. My PC sends another SYN. The web server sends another SYNAC. And this process just keeps repeating and repeating and repeating. It's not working, is what's happening here. And the reason it's not working is we're never getting the ACK back from the client. And if you remember on the inside PC side, that message was never getting the SYNAC. So we need to enable NAT to make this work. Let me stop my capture and close this. Actually, we can just leave this running because we're going to do this again in just a minute. We'll get a fresh capture when we do that. I want to move back over now to my inside PC. And I'm going to close all of my windows here. And what I want to do is open up my firewall configuration portal. And we're going to create a NAT rule. I'm using the Cisco ASDM here to configure the 5512 ASA that I have. We'll go into configuration and I'll click on firewall. And what I want to do is I'm going to create an object. Now, an object in Cisco land or in anywhere in networking and firewalling, really what it usually identifies as some networky thing in your system. So in this case, our network object that I'm creating here is going to be the network for the inside devices. So we'll call it inside hosts. And it's a network, and the IP address of the network, what identifies that network, is 10.0.0.0 with 255.255.255.0 as my mask. Now in the Cisco firewall, I can set NAT up quite easily. I just create it right within the object. It links the NAT process right to the IP addresses that need to get translated. So I add my rule. I select dynamic pat. And then I need to know what the translated address is going to be. Well, I'm going to translate this to the outside IP address of my firewall. The outside IP address of my firewall is 203.0.113.87. So that's what I'm going to translate it to. We're going to hit OK here and apply. What that did was it created a rule under my NAT rules saying allow the inside hosts to talk out to the internet, and when you do that, translate the source address to the outside IP address. Let's test to see if it works. So I'm going to open up Google Chrome and browse to HTTP 198.51.100.100. And there we go. Get my outside web server. Let's take a look at Wireshark and see what's happening in Wireshark here. So my inside PC is on my local side of my network. So when I capture the traffic here that's going to the website, let me put a filter in, ip.addr. And apply that. We'll open up Google Chrome again. I'm going to open up an incognito window here so that I get a very fresh, cache-less session. We'll browse to the website and capture what's happening. Stop my capture, scroll right up to the top. We have SYN, the SYN message we're sending from my inside workstation to the web server. We have the web server replying with a SYN ACK, and then I'm replying with an ACK, and then I'm sending my GET request, and we can see the whole transaction of the website moving in and out of my PC. Let's go take a look at what's happening now on the web server when I do this same exact thing. And specifically what I want to look at is what are the source and destination IP addresses. Now right now the inside PC, that is on our local side of our network. So let's see what happens when we look at the global side of the network for the same exact transaction. So I just moved over to my outside web server. Let me launch Wireshark. And we'll start capturing on my interface. And I'm going to put a filter in here that's going to capture traffic from both 203.0.113.87 or 10.0.0.99. So we're going to look for traffic from either one of those IP addresses. I'm going to go back over to my inside PC. You're not going to be able to see what I'm doing here. But what I am doing is I'm opening up another Chrome window and I'm browsing to the outside web server. So I just sent my request to go to the outside web server. I'm going to stop my capture here. Scroll up to the top. I got my SYN, SYN-ACK, ACK. But now on the global side of our network. My source IP address, 203.0.113.87, destination 198.51.100.100. There is no sign at all of the 10.0.0.99 IP address. That IP address is no longer reaching my outside web server because I have set up NAT now. In fact, if I just do a search for my 10.0.0.99 address, that no longer exists on my outside web server. So what the firewall is doing is it is creating a NAT entry and it's recording that transaction that's happening between my inside PC and the outside web server. In this next demonstration, what I like to do is demonstrate static NAT in operation. And I'm going to do this in two parts. The first part, I'm going to do a one-to-one translation where I have a unique public IP address that I'm translating into a unique private IP address. The second one I'm going to do is where we have only a single public IP address on our firewall, and we're going to use that to get to some inside resource. If we take a look at my demonstration network diagram here, what I'm going to start off with is setting it up so that the Internet PC can get to my inside web server. So I want a static NAT for my IP address 10.0.0.80 to my outside interface on the 203.0.113.0/24 network. Let's start with that. We'll come back to the drawing and look at what we're going to do next after we're finished with this one. So to get started with this, I'm going to open up the Cisco ASDM, which is my configuration utility for my firewall. And just like I did for my previous demonstration, I added an object called inside hosts, which are all the devices on my inside network. This time I'm going to add a separate NAT object. This time it's just going to be for a single device. So this object I'm going to call the inside web server. It's a single host and its IP address is 10.0.0.80. And I can give it a description here, inside web server. Then what I can do is I can add my NAT rule just like I did before. And this time I'm going to let it be a static NAT rule. And the address that I translate it to is an address that I'm going to pick on the 203.0.113 network. So I can pick anything except .1 and .87 because those two are already in use. .1 is my router's IP address out on the internet, and .87 is the IP address I'm using on the outside interface of my firewall. So I'm going to pick 80 to keep it consistent here with the IP address of the web server itself on the inside. We'll hit OK and apply. And that generated my NAT rule for my inside web server. I'm not too concerned about the details of how that got configured. All we need to know is that I just set it up so that my web server on the inside can get translated to the outside. I also need to add a rule. I needed to add an access rule to allow this traffic to come into my interface. I have since deleted that rule from the previous module, so we'll need to re-add that to our outside interface. Right now, our outside interface has nothing coming in. It will not allow any SYN messages to arrive on the outside interface and come in through the firewall. So to change that, we'll add a rule to that outside interface. The source address can be anything. The destination address, we're going to choose our object called the inside web server. This is something that Cisco actually did quite nicely, is that they made it so the administrator does not have to worry about when the NAT translation is happening. If it's before or after the access rule is applied, what we're doing is we just pull that whole object called inside web server, which has both the local address and the global address affiliated with it. I'm going to change my service here to be TCP HTTP so that only HTTP traffic is allowed. We'll hit OK and apply. And now what I should be able to do is go to my Internet PC and browse to my inside web server. Let's give it a try. So now I've just connected to my Internet PC. Let's open up Google Chrome. And what I should be able to do is browse to the website at 203.0.113.80. So HTTP 203.0.113.80. There we go. My inside web server comes up right away. My inside web server is at the IP address on the inside, remember, of 10.0.0.80. So here's where I can apply my static NAT to allow me to access my inside web server from the public internet. Let's wrap up what we did in this module. We looked at the history and need for NAT. We took a look at how dynamic NAT operates. We also took a look at how static NAT operates. And we finished up by taking a look at how port address translation operates. And again, this is the exact operation that's used in your home network. I hope you've enjoyed this module, and I look forward to catching up with you in the next module, which will talk about the DMZ. In this next section, I'd like to take a look at a more complicated process of NAT application called Dynamic Port Address Translation, or PAT, or Dynamic NAT with Overload. There's several words that describe this. Let's look at what it's doing, and then you can call it whatever you want to call it. You can call it PAT, you can call it NAT with Overload, you can call it Dynamic NAT, Dynamic PAT, all kinds of stuff. So Dynamic PAT works like this. Imagine your home network. In your home network, you have some type of connection to the internet, whether that be through a cable modem, a DSL modem, maybe satellite, hopefully not dial-up, but we have some connection to the internet. If you're a business, you might even have a fiber optic connection to the internet. However, in this case, I'm talking about very small networks, where we only have one single IP address to the public internet. Much like the last example I used for static NAT, where we only had one IP address to get out to the public internet, and we were able to manipulate the ports to allow that to work. Well, now here, imagine if I have two PCs on my local network, 10.0.0.10 and 10.0.0.20, and they both want to surf out to the internet at the same exact time. As a matter of fact, not only do they want to surf out to the internet at the same exact time, they want to surf to the same exact website at the same exact time. Now, we only have a single IP address on the global side of our network. So we only get one public IP address here to use, but we have to get both of these devices out to the public internet and back again. So let's look at how we do that. We first record all of our inside local and outside local information. So we're recording what each packet looks like on the local side of our network. So when we put these out on the global side of the network and we change our source IP address so that it can be routed back, when we do this in the traditional way that I explained in the first part of the module, what we would do is we would change the source IP address for the packet coming from 10.0.0.10. We change that to be 198.51.100.10, and we would do the same for the packet leaving from 10.0.0.20. So both of these packets now have a source IP address of 198.51.100.10 and a source port number of 56.487. Now the source port number here for both of these messages just happenstance accidentally happened to be chosen by both workstations at the same time to be the same number. What's going to happen here is when we try to get these messages back into our network, the destination, 198.51.100.10 for both messages, and both messages have a destination port 56.487. Well, we can't do anything with this because we don't know which message goes where. On the global side, the messages look identical, and we have no idea which computer they go back to. So when we're doing NAT like this, NAT can get confused and actually not operate correctly. So let's rewind this a little bit and apply port address translation to the traffic to make it work correctly. So now when we move these out to the global internet, we're going to treat each one separately. We'll start with the 10.0.0.10 address, and we will change that then to be 198.51.100.10 as the source address, with the source port as the same as it was before, 56.487. When we then move to the packet sourced from 10.0.0.20, what we're going to do here is we're going to change both the source IP address and the source port number. And that way, when we send this message out and it comes back now from the public internet, now we can explicitly identify each message. So when it moves to the inside of the network, we can look at the message coming from 198.51.100.10, port 56.487, see that that needs to get translated back to 10.0.0.10, change our message. And then when we look at the second message to 10.0.0.20, we'll see that it has a different source port number. We can actually do the translation properly now. When we're on a network that has multiple devices on the inside sharing one single public IP address, we need to implement this dynamic PAT, the port address translation, to make sure that all the messages that are originating on the inside that potentially have the same source port number get translated to a different source port number so that the firewall or the router or whatever NAT device we have there can easily translate between our single global socket now and our local socket for NAT. I'd like to finish this up by giving you some general NAT terms that can make your understanding of NAT much more universally applicable to firewalls. So what we've been working with this entire time throughout this entire module is source NAT, meaning that we are modifying the source IP address as the message moves from the local networks to the global networks. We're changing the source IP address and the source port number as the message moves from local to global. We can also do destination NAT or some combination. Destination NAT means that we're actually going to change the destination IP address and or port number as the message moves from local networks to global networks. Using destination NAT or a combination of source and destination NAT at the same time, these are uncommon and are used in special applications. The cases that I've seen destination NAT used most often is that when you're trying to build a VPN tunnel with a small organization and the IP space that they're using in the small organization overlaps with the IP space that they need to connect to in your organization. So you have two organizations both using 10.0.1.0/24. You have to do some type of NAT to make that work. You don't necessarily need destination NAT, but my experience has been is when you're working with a very small IT shop and you're a very big IT shop, as was the case for us at UW Hospital, we found that sometimes doing the destination NAT allowed us to solve problems much faster than what could happen if we turned it over to the very small organization that may have had only